CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaca UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 17 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can, as then you'll be able to watch the playbacks of all sessions in the conference until December 30. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session by Phil Wikins. Please, making system and application logs delivery more valuable. Please feel free to post questions at any time by using the chat window in your right lower corner of your screen at any time, and Phil will be answering all questions by the end of the presentation. If you have any issues or problems during this session, please feel free to use the same chat window in your right lower corner, and I will be trying to help you the best I can. Without any other further ado, I would like to leave you with this amazing session by Phil Wikins. Phil, the room is yours.
Thank you very much. Good morning, good afternoon, or good evening, depending on where in the world you are. So I hope you find this session useful and insightful. It's certainly not an area that many people consider or look at. Maybe a little unsexy, but very, very important. And hopefully we will have made things a little bit more interesting and a bit more insightful for you by the end of this. So let me press on and give you a little bit of an introduction to myself. So father of 2 boys. I'm a blogger. I'm an author of several books, 2 specifically on Oracle, and a third one will be out in print in the new year around Fluentd. I am a consultant and a technologist for my employers, Capgemini, and they've given me the label of a tech evangelist because I'm the one that gets out talking to everybody. This and lots of other material you can find about a number of Oracle areas of interest for me through my website, mp3monster.org. So don't worry about trying to scribble notes or anything like that. It'll all be available there. And of course, there's the recording that you've got over the next month to play back as well. So when I'm not delivering for customers, I'm helping run a developer meetup in London. At the moment, things are virtual with COVID, but you never know. 2022 might give us a chance to run something physical again, which will be really nice. Actually get to talk to people. And of course, blogging and writing books, and this is the one that's due out at the start of next year, as the editors are just polishing off the last little tweaks, ready to go to the printers. I mentioned Capgemini, so my time is paid by Cap in the UK, and we're fortunate to have a very successful growing team. So if you're interested and want to join us, then reach out. It's an award-winning team, so we're very proud of what we're managing to achieve. But less about Cap, because this isn't a sales pitch. It's all about logging and monitoring. So let's start by putting things into a little bit of context. So depending on your role and the way you work in IT, your perspectives will vary on what logging and monitoring is and how we're collecting that data. And it's quite interesting how, as a developer, you'll see the world very differently from a DBA or an infrastructure specialist. And over the last few years, we've seen some evolution in the thinking and the ways we describe and approach this very subject. And one of those ideas is called the three pillars of observability, which come about as metrics, which is kind of the numerical representation of the monitoring, how much CPU you're using, how much memory, how much disk, those sort of figures. Then we've got logs, which most app devs will understand, or if you're working at the lower levels of OS, you'll still be involved in thinking about SNMP traps, Audit-D, and technologies like that, which give you a more descriptive view of what's going on. And then traces. If you're a SOA developer or an ex-SOA developer, traces will be vaguely familiar to you because we used to talk about ECID. Now we talk about traces. It's the same basic idea, tracking a transaction through many, many different components in our enterprise solution, whether that be infrastructure components such as our network, load balancers and things like that, or actually our core applications, be that WebLogic or a microservice. And we can actually look at that, those three different pillars, and look at the different layers of a solution. So, on an infrastructure perspective, you're going to see a lot of metrics-based monitoring data, but you will see some logs, but not really into the world of tracing. And as you move up the stack into virtualization and containerization, you start to see a little bit more of the logging and just the vaguest of hints of traces, perhaps, particularly if you're running a Kubernetes environment. We add another layer and we're into the application ourselves. And here you can see actually metrics are probably moving into the minority, and we've got a lot of logs, and more modern distributed solutions will be thinking about tracing, or will have trace style mechanisms. And then we go all the way up to business activity and the business perspectives. And we see more of the trace because we're now looking and thinking as a business, how are my orders progressing through an environment? So you're looking at individual transactions and how transactions are flowing, or whether they're getting stuck in the systems. So tracing takes on a slightly different dimension, but it's still the same basic idea. And of course, either side of that, we've got things like measuring for capacity, so we can auto scale if we're into the cloud, or got plenty of spare capacity. If we're not auto scaling, we're probably still watching it to make sure that our systems don't start to slow down because they're saturating. And of course, on the other end of the spectrum, you've got to think about the security. So what's going on? Where is it going on? And what are the interactions doing? Can I track someone trying to move through my network with malicious intent? Are they tripping off things like security logs and things like that because of poor credentials? So it's relevant to just about every aspect, and particularly cloud, as we talk about infrastructure as code, but it's just as relevant for on-premise solutions and even our legacy environments. And in some ways, some of this is actually more critical to those because your legacy environments are often the ones that people don't want touching or changing. And as a result, the only way of actually finding out what's going on is to look at logs and analyze them. So our use of logs quite varied, surprisingly varied when you look at the full range of possibilities. So, trying to find those unexpected, unhappy events occurring, that's the most common use case. But we're also looking at logs for performance. The classic one, if you're a DBA, is you'll be interested in slow queries and how they're being recorded. If you're a security person, it's who signed in, did what and when. so you can work out whether the system is being used properly, safely, or you've got someone trying to break into your environment. And of course, at the bottom line is all of these different views have got to come together to give us a view that helps the business. All right, so we want trying to bring these different viewpoints together to give a holistic understanding of what's going on. And at the end of the day, it's got to support the business value. If we can't align or explain why a monitor is in existence and how it supports the business story, at the end of the day, you're going to get questioned as to why we invest in effort in it. So the bottom line is when we're thinking about monitoring, how does it support the end story and the organization? And then, as I mentioned, I've talked about microservices and things like that. What we've seen over time is that the technology landscape is getting more and more complex. And as a result, we're getting logs from more and more different services and components within our landscape. Back in the 60s, we used to have applications that were just one application running at any one time, and it wrote to a file. And so if something went wrong, you'd know where to go looking. And then we started to see concurrency through threads and multiple CPU cores. And then we saw asynchronous behavior growing and growing. Today we look at that through Kafka, but if you go back, we had JMS and even a little bit of asynchronous behavior by using databases and file systems as data exchange points. But today we've got the whole gamut. We've got threading, we've got multiple CPUs, we have separate processes. We have different application models like Node, which is context switching to maximize how a single thread is used, through to older solutions where we are creating many, many threads and parking those threads as things stop and start, and we have to wait for events occurring elsewhere. So it's become increasingly complex, and that's put more demand on what we can do and how we handle logs and the other measurements that go with it. So as you can see, we've got the evolution and the complexity going there, and as sure as we can be, we can assume that things are just going to get more complex, and as things move into, perhaps we see an increase in growth in functions and ephemeral processes. That's going to be the next level of complexity. So that all leads me nicely into Fluentd. Fluentd is a tool to help unify and get log information together and collect it. So let's look at its capabilities. So it can capture inputs from many, many sources. It can then push those events to many, many different destinations, whether that's just chuck it all in something like Elasticsearch or Splunk, as many people use, or feed the data into Prometheus to do time series analysis on the log events. You got a lot of power there. But it's not just that story. We've got to be able to store these events and cache them to give ourselves optimization and performance and assurance that we aren't going to lose information. We need to be able to take what is quite often semi-structured information and apply some meaning to it. So that we either parse it because it's some sort of structure, we just need to make it easier to use, such as taking comma separated values and mapping it into JSON, for example, and filtering out content. Some messages we might want just to see that that everything is running hunky-dory, but we don't want to capture and record those events for prolonged periods. A classic one of those is if you've worked with WebLogic containers, you'll know that WebLogic is constantly logging that everything is okay Whilst that's valuable because it assures us that the process is running smoothly, particularly when it's quiet, we don't really want to persist thousands of "it's all okay" messages into our log analytics capability. We can characterize the journey and life cycle of log events by looking at this path through the capture of those events from whether that be a WebLogic server or an Oracle database or Oracle Linux or any other flavor of database and app server and storage, into then trying to apply that structure and determining where we need to put it. Because in many organizations, particularly the larger ones, we'll end up with teams that are dedicated to specific tasks, such as security teams for these application support, or DevOps teams where the developers are also the operational team. And then we need to collect that data together to actually try and not only find individual error occurrences, but look at trends. Are errors building up? Are we seeing more problems? Or are we seeing less? And that leads us into how do we visualize this? And off the back of that, we want notifications. We want proactive alerting. Now, a lot of organizations tend to look at this last phase as what the analysis they do off the back of their Elasticsearch or Splunk or Datadog products. But by waiting that long, as you'll see shortly when I do a little demo, that can be too late. We really want, if we can detect a serious event because we've applied some structure and recognition to a log entry that says, the whole thing's going to collapse if you don't get in there and sort something out in the next 60 seconds. Then we want the log management to be able to do that, not go, okay, I'm going to store it, and then every few minutes I might run some analysis over the last 30 minutes of log events I've collected, and then I might raise an email alert. We want to be a lot more proactive, and that left-hand side, that's where Fluentd is really at its best. For the right-hand side, for the visualization and notification, Fluentd is not geared up to do that, but what it can do and is really strong at is being able to put that data into a tool that will give us exceptionally good visualization, interact with notification tools, whether that's Slack or creating Jira tickets or using PagerDuty or anything like that, or even good old-fashioned emails. So it leverages tools and products that are better for that kind of activity. Now, if you're in the open source community, you will, as a developer, you'll have probably heard of the ELK stack, the Elasticsearch, Logstash, and Kubernetes stack. And the stack is there. It's a good, solid, proven set of technologies, but it has some downsides. It's a reasonable technology stack, but it's not always fantastic for certain things. The footprint for these technologies is not as efficient as Fluentd, and this has given rise to the arrival of what's known as the ELF stack, which is replacing the Logstash layer with Fluentd and Fluentbit, and still using Elasticsearch because it is a good tool for aggregation and analytics, and Kibana is a good tool for visualization. But Fluentd and its baby brother Fluentbit, which is the equivalent of the Elasticstack's beats component, is a lightweight component, lightweight version that's great for deploying into IoT and very small footprint scenarios. But Fluentd offers a differentiator in terms of it's so much more pluggable with about 500 different sources and targets that you can support, along with caching and other things that we've already mentioned. So it is very, very powerful. So I've talked a lot about Fluentd. How does this tie into Oracle? Because this is, an Oracle-based conference. So it's worth noting that if you're working with Oracle Cloud, OCI, and particularly Gen 2, the Oracle logging framework that's under the hood that you can use is based on Fluentd, which makes it really easy for them to then integrate and capture sources that are conversant in Fluentd, and to also share log events that is picked up back out to Fluentd. Particularly helpful if you're thinking about multi-cloud, because Fluentd is a CNCF solution, and therefore actually very pervasive, and appears in a lot more places than you realize. And so not only do Oracle have it under parts of it under the hood, so does Google, so does AWS, and a number of other providers. But it goes further than that. Some people, if you're in the app space, will have also come across Verrazano. Verrazano is a relatively new offering where Oracle are approaching the problem of multi-cloud by going for creating a pure play CNCF-based solution stack, which they've then extended to allow things like WebLogic to deploy straight on top of it, and using the WebLogic operators and things like that. Coherence is another one that's natively running on Verrazano, and that uses Fluentd at the moment. Now that gives them a framework and a technology stack that they can run on any cloud. So you can deploy anything that will run on Verrazano on OCI, AWS, or GCP, or Azure very easily. And then, of course, I mentioned the log analytics, and you can see this diagram here at the bottom right, actually comes from Oracle documentation. So you can see it picks up lots of different log sources. You can use Fluentd to feed the log analytics. And that's great, particularly if you're running a hybrid or a cloud, a multi-cloud use case, because you can use one tool to collect all the information, but make use of Oracle's power and understanding of being able to mine data and doing data analytics. So I mentioned examples, so let me introduce an example. First of all, we'll just have a quick look at the config. This is how we configure the Fluentd nodes. It's a sort of a hybrid between XML and YAML in appearance, but whilst it looks a little bit strange, it doesn't take much to get to grips with it. Essentially, the XML elements are the key building blocks, and the more YAML-like are the configuration values for any of the building blocks. Now, as we go through this, you can see I've got sources, which is where I'm collecting my log events from, and destinations, where I am putting matches, which are the destinations where I'm sending things. And you might notice in the middle, I've got a chunk there that I'm describing how to write to a file, and it deals with files and log rotation. And I'll also be sending certain log events straight out to Slack, just to illustrate the point of it's very, very easy to drive this. But let me show you architecturally how it hangs together. I have one node, which I could distribute into many, many locations. Let's assume that this is supporting an app in a more traditional deployment model. So we could have a Fluentd there, and it could be saying, look, I'm just going to pump out to a local file all the log events in a structured manner, including all the events I gather from different files. So I've got a consistent time series view of everything. So I don't have to look at 3, 4, 5 different files, which you may end up doing if you're running a solution perhaps fronted with a Tomcat or an Nginx and an app server, let's say JBoss behind it, and maybe some sort of in-memory cache, Memcache or Redis, all on the same machine. So you can now bring all those logs together locally, and we're just going to drop them into a time series file. But I'm not going to transmit all of that information. So we can deploy it, distribute the same configuration in multiple locations, and then we can use a folder to actually send the important stuff to a central location. So we effectively concentrate the important information. So, if it's a significant event, we can send it to a central node to be processed with a bit more depth of detail. Here I'm using standard out, so it's just right into the console, but you could imagine that is your log analytics tool, recording meaningful events. And in the process of doing that, I'm also looking for specific events that might have a keyword that could be simply looking for the word error. In the little demo I'm going to show you, I'm going to be simulating log events being generated from an application, and I'm going to be filtering and looking for any references of computer and sending those to Slack. So of course these need to be networked together, which is what we have there, and it's very, very simple to set this up. In fact, from zero to having the demo going, once you're familiar with the notation for the configuration, you could probably do this in about half an hour. It will take you longer to get through Slack and find your tokens that you need to actually identify your API calls and credentialize yourself. So let me drop out of this for a moment, and we'll come over here. I've set up 4 little windows here. So Fluentd is a very, very small footprint. So I can run 2 instances on my machine here. So let's get these up and going. As you can see, I'm just saying, okay, here you go, run with this config file. That's one of them. And you'll see it starting up. It's just published what its configuration is. And we'll start the other one up. So one of these is simulating the distributed node, and the other one, the bottom one here, if I recall correctly, is the one that is going to be effectively my consolidated single node. Now, what we've built and we now use as part of a CAP offering called Agile Innovation Platform is a log generator. And what it does is it takes a log file, which can be structured in a number of different ways, and replays it for us. Now, in this case, I'm replaying it very simply. But if you want to test your configurations and your setups and monitoring, not just Fluentd, this will work for other things as well. You can take particularly unhappy paths, which are difficult to create. You could take a log file and replay it through the log simulator, running into your monitoring suite the log events. Now you can see my central one's the top one, and you can see it's pushing out to the console log events that it's receiving. And any time soon, you'll probably start to see my Slack node, Slack pinging away. If I go over to here and bring this into the screen, so whilst that's getting going, it's caching up and it's sending Here we go. So literally, this is the first one. It's sending to my Slack events that is picking up with references to computer. Now, this might be as useful as a chocolate teapot in the real world, but you can see this is a quite realistic capabilities. When I talk about this idea, it's very, very easy to achieve, and it doesn't have to be Slack. It can be whatever framework that you want, whether you're using Microsoft Teams or something else, and you can route it through. In this case, I'm sending it to, if you know Slack, you'll recognize that this is just a channel. But you can route it to individual users, or you could use things like PagerDuty. So there you go, it's continuing to pick them up as the simulator continues to flow through. So little demo, very simple. We've got just about enough time, so what I'll do is I'll just pop up my IDE. So you can see that there's my config for one of my simulators. This is my source file. So in here, I've constructed it where I'm saying now, this plus is the time duration between sending each of these events. But it can pick up a log file and say, okay, you tell it where the timestamp is, and it will go, okay, right, I'll work out from the deltas on each of the timestamps how long to wait before sending the next log event and sending the next one. So it replays it as if it looks like it's in real time. And then if we look at the configuration files, here we go again. So again, here's the source, and it's tailing one of the files that my simulator is generating, parsing it into JSON, and then putting it into a pipeline of activity. And that's doing a couple of things. It's looking for log events and putting them into the pipeline, and then I have got a match, which means it's effectively deciding where to put it. You can see part of the little bit of latency that's in there is because I'm using a buffer to optimize my I/O. So I'm chunking up and I'm flushing every 15 seconds, or when I hit 50 events in the buffer before I push out to the other node. And you can see that it's forwarding to another node, and that's just using my local host on that port. So I can then pull up the other configuration, and here it is. It says, okay, I'm going to take things from that port, receive it, and I'm going to put it into a label stream, and then I'm filtering it, looking for the pattern of computer. That means that I'll pick up a capital C or a lowercase c just as easily, although I could have put a smarter regex in there. And then I'm matching, which means an output, and sending it to Slack. And you can see, look, there's my username, and I can build up the message and do all sorts of things. And I'm caching up for every second before sending. And that's it. So very, very simple to establish this. So let me come back to my slides. So in the real world, the challenges are more significant. As I say, nice little demo, but that's where it's at, and you may be working with a lot more complex space, dealing things like many applications. You may be dealing with Kubernetes and needing to think about the different patterns that you require to use with a Kubernetes configuration, whether that's a sidecar design pattern, or you need to actually capture the Kubernetes or Docker logging. And Fluentd is one of the options for Docker for acting as a listener. So even if you're just running native containers without the Kubernetes orchestration, you're up and running very, very quickly. We can do lots of clever things like processing log events without affecting our host machine, or negligible impact insofar as that we're just going to grab the log events and bump them off to another destination where we can afford to invest some more compute effort into analyzing the logs. Something that if you're on a legacy system, people are going to be a little bit nervous about you creating an unnecessary compute load. Okay, and let's just look at the different scaling options. So here's one. This is a traditional one where we were lots of applications running in a distributed manner, and we're consolidating. So this is effectively the kind of idea that we had in the demo, except I was only running effectively one server on the edge, and I'm consolidating to the single center. And my persistence off that node was actually a log file. But we were then going to an alerting service. In our case, that was Slack. And you can do this in clusters. You can do this in highly distributed. So you can do it multi-cloud, and then just share the key events so that you're not chewing up your bandwidth, sending unnecessary log events to a central repository. And that's quite important and helpful if you're dealing with hybrid use cases as well, where you might be using cloud to do bandwidth bursting and things like that. So this could be your on-prem, and this could be your capacity in the cloud to burst, but you still need that central view and the analytics, particularly when you start looking at security events. Is any particular user trying to do something that they shouldn't be doing, things like that, and is there a pattern of poor behavior? And of course, I've talked about Kubernetes, so we can look at it in containers like this, where we're just literally analyzing what Kubernetes yields, and the pods follow the 12-factor model that says, just chuck all your logging to standard out and let the orchestration and infrastructure gather up your logs. Great, but it's very inefficient and hard work to make those log events meaningful. And you can see here, I've got pods here where I'm not using Fluentd, but Fluentd. The two can talk together each other, and Fluentd's just an even smaller, lighter weight version. And therefore, I've put a Fluentd instance in each pod because it's such a small footprint. And then we can use the sidecar pattern if you're into containers and the different deployment patterns that Kubernetes uses. That's one of the more common use cases for deploying Fluentd into a microservice use case. I mentioned the two, so let's just quickly summarize the differences I have touched on. So Fluentd is the far more suited to the diverse collection of log events. It's got the abilities to do a lot more processing of log events, but it carries a slightly bigger footprint. Whereas Fluentd is a very small footprint with a limited set of plugins, and as a result, limited on what it can do. But it's great for things like just deploying it into IoT and those sorts of things. But Fluentd is small enough that you could run it on a Raspberry Pi quite easily. I mentioned that there's different stages, and this diagram is a sort of a composite of a couple of use cases. Composite, because I wanted to sort of mask who we built this with, but we built a fairly extensive solution space which we're monitoring. It was multi-cloud, it was on-prem as well, it was distributed around the world. So what we were doing is gathering from a whole range of different sources, from VMs for some legacy solutions, Kubernetes environments, simple Docker containers as well, and some native application deployments, primarily Java, but not exclusively. And in addition to that, some of those applications, when they were in the Kubernetes environment, was using the open tracing standard, which meant that we were also supporting the use of a tool called Jaeger and its collection and analysis of those traces. That didn't stop us collecting that trace information into Fluentd as well, so that we could use the traces to drive some numerical metrics-based data through Prometheus, and just do bulk analysis, application analysis through Elasticsearch, fronting it up with Kibana. And then, as you can see, a few things, a few critical events that we were looking at, such as when we were seeing CPU utilization hitting the roof on VMs, or disk storage getting to the point where the machines have to do swapping and losing efficiency. Those were triggered as notifications so that they could be remediated before it became critical. And you can see how that all relates to that life cycle I described at the bottom. Yeah, so the capture, the structure, work out what's important, and pass it on, route it on to different places. So the security team were insisting on using Splunk, but the devs were using Elasticsearch. And of course, then into notification channels. So, normal routine errors would get a Jira ticket. So that we could see when they were being raised and things like that. And then we had visualization of various tools like Kibana or anything else that people wanted to use. So that's a real use case, and it was a pretty substantial use case as well. So that's my presentation done. And we've got about 5 minutes to look at any questions. So let's have a quick look at what people have been asking.
Hi, Phil.
Hi.
Thank you so much. Very interesting session. Very excellent content. I'm just giving time to the people to see if anyone have any questions. Up to this point, we have none in the chat. I'm just waiting the people to give them some time and a chance to post anything. In the meantime, I want to say thank you so much. I know for you it's very late in UK. Thanks so much for taking the time to do the presentation live. If anyone has any questions also watching the replays of the session, on the screen you have basically all the contact options you have to contact Phil. You have his LinkedIn, you have 2 Twitter accounts, you have his blog, and basically you can contact him with any questions directly. If you have any issues getting in contact with Phil, you can contact us at Apaco UC, and we can relay your questions to Phil with pleasure. Saying that, looks like there's no further questions from the people at the moment. Thank you so much, Phil, and please take care and be safe.
Yes, thank you very much, and thank you for hosting us. I hope the conference continues as successfully.
Thank you, and have a wonderful weekend, everyone.
Yeah. Good
Bye-bye.
Night. Bye-bye.
CloudDB, shaping your new normal.